discussing construction materials, trends, and testing. And this is our revised version because we already had our former version of this in the past. And Dr. Anna would be able to explain that to you later on. And this is presented by Dr. Anna Evangelista, and she is one of our lecturers and course coordinator at EIT. And before I hand you over to Dr. Anna, I would like to address some common questions that you might be asking later on during the webinar. So first question is, will we get a copy of the slides or the video recording of the webinar? The answer is yes. You will be receiving a copy of the PDF slides and also the recording of this webinar. Okay, and that will be emailed to you within the next 2 business days from today. And of course, please make sure to monitor your junk email or junk inbox so that you won't be missing this email. And second question, will we be receiving a certificate of attendance? The answer is yes. There will be a digital certificate of attendance for the live attendees for this topic. And later on, I will be posting, or we will be showing, a QR code on the screen where you can scan on your phone and you can register through a short form, or there is a link also that we will be sharing later on in the chat so that you can request for the certificate of attendance through that link. So make sure that you request that up until Sunday night for you to make sure that you get your certificate, and it will be emailed to you by next week. All right. Now let's go ahead and have a quick idea about EIT. So EIT is, of course, a dedicated institution that ensures that all of our students would receive a world-class education and gain skills that you can immediately implement in the workforce. And of course, we are one of the only institutes in the world specializing in engineering, and we deliver a variety of courses from professional certificates, diplomas, advanced diplomas, undergraduate and graduate certificates, bachelor's and master's degrees, and a Doctor of Engineering degree as well. And we have industry-oriented programs. So our programs are designed by industry experts, just like Dr. Anna here. And that is our way of ensuring that our students would graduate with cutting-edge skills that are valued by employers, not only in Australia, but also worldwide. And we have world-class Australia accredited education. So we have vocational programs and higher education degrees that are registered and accredited by the Australian government. And we also have programs that are also recognized under 3 international engineering accords by Engineers Australia. So we have the Washington Accord, the Sydney Accord, and also the Dublin Accord. And of course, we also have our industry experience lecturers. So our lecturers are highly experienced engineers and subject specialists with applied knowledge in the engineering field. And of course, we have state-of-the-art technologies for both online and on-campus studies that will enable our source or our lecturers from a large global pool of expertise here. And we also have a unique delivery model, and our programs would follow a unique methodology. And of course, we have both live and interactive webinars and an international pool of experts of lecturers, just like mentioned previously. And aside from that, we are proud that we have our dedicated learning support officers. So in every course, we have an assigned LSO or learning support officer that would serve as the go-to person of the student if the student has any concerns regarding his or her studies, and a lot more support that we provide from our academics team, and the equipment and the technologies that we also provide our students. And that's it about EIT. Thank you so much for spending time with us. And I will now hand you over to Dr. Anna Evangelista, and she is our presenter for today. Dr. Anna, it's your turn now. Thank you.
Thank you very much, Lisa, for a very nice introduction, and welcome everyone to this webinar, technical webinar. Yeah, I'm here today because I'm passionate about engineering materials, construction materials. I'm a civil engineer, and currently I'm course coordinator at EIT, and I'm also teaching bachelor's degree units, master degree units, and also supervising the eng students. And yeah, this is about me. And now let's have a brief idea about the session today. We'll be covering some materials trend and testing. This is the reason we all are here today. So we're going to be able to discuss some eco-friendly materials. We're going to discuss different types of tests, not in details, right? We only have 15 minutes, but it's just to give you an overview regarding the new technologies in this area. We'll be showing some examples of non-destructive tests, non-destructive tests, and at the end, we have some session, Q&A session, okay? So you can pop up your doubts in your chat box when possible. And let's start. I need to start with this question. Do you have a favorite construction materials? What type of construction material is your favorite? Do you have some that you can share with me? And then I can share the one that I really love. Any ideas? What's the most popular construction material? Let's have a look. Concrete, steel. I'm really glad that, yes, there are lots of concreters, lovers here. And timber, that's great. Thank you. Glass, bamboo are really great. Bamboo, timber. So yeah, we're going to be talking about different types of materials today, okay? So that's why I just want to introduce this type of big ice break, just to familiarize ourselves with the topic. And in a sequence, what we can see here, there are iconic examples around the globe. If you think about the different types of materials, traditional materials, we can say, right? We have examples over the last decades or more than this, right? If you think about Rome and all the examples we have, and it refers us to different types of material. Timber, we have concrete, we have different types of rocks, and then we have steel as concrete. So Eiffel, it's one of the iconic examples we have. So this is just to give an idea about how traditional materials can evolve over time. New technologies under this area are coming every day, every new day. And that's why we need to work collaboratively with our colleagues, architects, and then we can come up with these very special types of design. So our main idea when you're talking about materials, you have from one side the design aspects and the other one the selection of materials suitable to a specific type of project. So this is the reason why it's from my point of view as a civil structural engineer, we need to understand materials characteristics, materials behavior, how we can evaluate concrete properties in order to understand what's going on in situ. So this is what you'll be talking. If you have trouble hearing in terms of listening to this session, sometimes you just need to log out and log in. Okay? Yeah, thank you, Jean. And then here we have just an idea about evolution of materials over time. As you can see, at the very old ancient times, we have metals, then progressing, moving forward until we have this new technologies of the metal materials at this stage. polymers, elastomers. We can consider timber, some organic fibers. From the old types, we can consider these as under this big family of polymers. And now what we have, these new materials coming here with showing high modulus polymers. So it depends on the type of application in different engineering areas. First step is to understand that we need to characterize materials against its family. And regarding new materials, the current trend we'll be discussing more in the future slides, we have the hybrid materials when we talk about composites, right? This is when we can just not sure if you are familiar with this type of materials like carbon fiber reinforced concrete, fiber reinforced concrete is becoming more and more common nowadays. And another point is about, as engineers, that I really want to show you here is about what's going on, right, in terms of the new designs. When a new material is required, it's pretty much because the design requirements, you have the design, structural design to accommodate. So that's why this is, I think this is really nice example from this bridge in China. It's my perspective, it's beautiful, and it's not about only about the bead, it's about different types of materials they could work here, because when they decide to go with the, for example, carbon fiber reinforced polymer, so they could just accommodate the architecture design, this type of aspect. So depends on the type of material. Here we can see it's about offering high strength and durability, but we need to think about the weight of the material. Otherwise, we cannot accommodate this type of design, right? So, and then another point we need to think when selecting materials more and more about environmental impact and construction time, right? These are our main challenges as engineers nowadays. And another point that I'd like to bring to this discussion today, it's about why we need to consider economic, environmental, and social issues when we are talking about construction materials. There is no doubt nowadays, engineers, we have a huge responsibility regarding sustainable development goals. This is from United Nations, and here I'm just sharing with you two of them. This one, the number 9, as you can see here, the main idea is how we're gonna be capable to work with more resilient infrastructure. And at the end of the day, it's about at the moment that you are doing your project, and about that you are creating your new design, selecting materials, depends on your project. So we have some huge responsibility here and about building up sustainable infrastructure. And another point that I really like is about sustainable cities and communities. So when you think about sustainable cities, more and more we can see around the globe in different countries the issues around housing, right? Demand of construction for new house. And here is our responsibility at the moment that you need to make decisions about a new project. This is one of the points that we can consider. Because if you don't think about environmental impact, here how you can live in a sustainable city, it's a lot of pollution, depends on the type of material that you'll be working with. So here is just to give you some initial enlightenment regarding United Nations Sustainable Development Goals. I encourage you to familiarize yourselves because this is what we need to deal with as structural, civil engineers, construction professional, architects. And my point here is about low carbon materials for buildings and constructions and the transportation infrastructure, right? So this is, if you only target one goal here, that's a lot that you can contribute, okay? So this is to give you some ideas about the sustainable development goals. And now we have another example of a trend This is an iconic example from Amsterdam, Netherlands. Here is about example of sustainability, right? Here is an iconic building. This type of building, they just match all the requirements regarding the sustainability aspects. So that's why this is considered the greenest building around the globe. It's about using recycled materials, reuse of construction materials. What type of materials? The ones that we discussed at the very beginning: concrete, steel, glass. So it's possible to reuse in a safe manner, and that's why we need to consider the technical aspects. And for the design aspects, that is not our main goal today, but we also, at the moment that you're selecting materials, we also refer to energy efficiency in buildings, right? In addition to install and incorporate solar panels, LED. So all this also connected with our selection of materials. So this is the part that I'd like to create your awareness, because materials trends, there is no type. It's about carbon dioxide emission, it's about energy. The energy sector, we are our industry, construction engineering. Yeah, they blame us a lot regarding carbon dioxide emission because of production of cement, right, and concrete later on. So that's why when you study construction materials, engineering materials, applicable to civil, mechanical, electrical, if you want to work out the entire life cycle of your product, this is one of the key points: embodied energy. So that's why here I'm not going to the details how to calculate embodied energy, but it's an opportunity to open your mind, and later on you're gonna be able to dig down here. So we have the initial embodied energy for the construction. Here you can see the energy to produce materials, right? And then you have your building. So here you have other points, the operational energy use. And then end of life, it's possible to close the cycle. Let's say you have the demolition of your building. You can reuse your material, like recycled concrete or construction demolition waste, and then you can reuse it. So you can mitigate part of, you can have some recovery of the energy, the embodied energy you have your material presented here at the very beginning. So different types of materials have different levels of embodied energy, but this topic is becoming more and more common when we are asked to select materials, right? This concept. So moving on, when we talk about energy, pollution, we think about in our industry, low carbon concrete or recycled concrete. This is one of my examples because I think there's a lot of research around this topic. The main idea is just to ensure that we can do better, right? Our main problem about carbon dioxide emission, CO2 emission, it's about cement production, right? Manufacturing process of cement Portland. And when we can replace cement and use, let's say, 30%, 20% fly ash, slag, or silica film, these are byproducts from different industries, right? Different sectors. This is one of the alternatives we have to minimize carbon dioxide emission regarding the manufacturing process of cement. And on top of that, recycled concrete, as you can see here, we can use as aggregates. We can replace natural aggregates. Why? We need to always work with natural aggregates. Depending on your project, now we have the codes that we can follow in order to use recycled aggregates and replace the natural materials. And what's the problem to use natural materials? Can you tell me in the chat box? What's the problem to use natural materials? What's going to happen in 200 years, 300 years, or less than this? What's the benefit to save? It's the pleasure, right? Yes, Nelson, thank you so much. So in different aspects, green construction can definitely, all these, we need to think about our future and the future generation. And here is about, as I mentioned at the very beginning, you have different types of concrete you can produce, fiber reinforced concrete. And here is just to give an example, in different countries, we can use natural fibers, let's say coconut fiber, right? And we need to be careful regarding deterioration over time. There's a lot of research around this topic and application as well. But we can also remove fibers from the steel, steel fibers from the tire waste, right? And then it's when you think about the concrete, we think about cracks. And when we incorporate fibers in our concrete, yeah, do you great one, Mary? Banana fiber, yeah, this one, it's new for me, but I will search more about this one. I'm always open to receive new inputs if you have. All these new materials are coming to our life, to our projects, because more and more we have composites, right? It depends on the type of application. What is composite? When, for example, natural composites, when you have more than one material combined, ingredient, we can say, let's try to simplify. For example, timber, it's considered a natural composite. Bones are composites because they have more than one ingredient, right, to form the final product. And we can have man-made composites. Yes, the bonding, Sami. So composites, what's the main purpose? To combine more than one type of engineering, timber, paper, concrete, reinforced concrete. So these are the man-made composites. And it's not new, ancient times, there are some applications. And nowadays, what we have the modern type of composites, like the fiber reinforced polymer composites. In this case, is an example of application when, let's say, this column needs some reinforcement, extra reinforcement, so they could wrap this column with this type of composite. Alternative, so we should also add steel bars, and have another formwork here just to make it bigger and bigger. But that's why these challenges come, right? So here we have some initial ideas about composites. It's just to move on. When we started this session, we talked about traditional materials. Now we understand the need to stay up to date and upskill regarding materials, trends, and testing, because we never know when you're gonna need this in your projects, how you're gonna go and work in your project using the new materials. It's a shame if someone asks or talk to you about a new material like a fiber reinforced concrete or fiber reinforced polymer bar or glass fiber reinforced concrete, and you don't have a clue. You don't have any idea about this. So it's always opportunity for us to absorb more information. Okay. And yeah, regarding the trends, I'm gonna give you your answer at the end, okay? Okay, Raj? So here we have other trends. For now, I'm just exploring all the trends regarding use of polymers, and you can combine with cement and use in applications in pavements in order to improve stability. Reuse of asphalt, that is something you can reuse asphalt to produce new ones, and definitely it's gonna mitigate environmental impact. If you think about timber, more and more we need timber, engineered timber showing higher strength, right? And that's why you have this type of composite, cross-laminated timber. So this can be used in order to, when you have buildings as well, as structural elements. So another point, I will stop here. when you select materials, step number one is to understand if this application you're gonna have a structural purpose or not. So if it's not, you can be a little bit more relaxed. But if there is a structural purpose, you need to double check your attention, okay, regarding the design aspects. And now, under the umbrella of concrete technology, there are some research and application regarding self-healing concrete. It's bacteria that are added in concrete because over time, this can be useful to repair cracks. Quite interesting, right? Have you heard about self-healing concrete? Yes or no? Oh, good. Thank you, Molly. Thank you. Yeah, that's why I'm trying to share with you the most recent technology in this area. And here is about suitable smart glass, another type of new material here, very new. When you have nowadays, you know, our concern is about UV protection. And then this can also, remember at the very beginning, the greenest building in Netherlands about energy efficiency. So here you can see one of the alternatives is the application of smart glass, 30% on energy cost. So this type of information I retrieved from literature, and then at the end, you're gonna have all the reference for you to explore a bit more in your own time. But it's not only about empowering parts, it's not only about how we can contribute to save the planet. We need to keep in mind when you work with engineering materials standards, right? We just need to follow standards, depends on your country. Uh, this my main idea here today. Every time when you are involved in a project, first step is to familiarize with standards available. Okay, I'm not saying that you need to download standards every time, but I'm saying familiarize yourself. At least go through the standards website, type the type of material you are working, and then you're gonna see how many standards you come up. Here is one example from the Australian standard, the concrete structure. And there are, when you have one standard, you have so many others, right, to refer to. So familiarize with standards all the time when you need. And you have the ISO standards. And just to give you some idea about materials and ISO, we have more than 100 standards related to raw materials. And what type of raw materials I'm saying here? Concrete, timber, glass, cement. So all these are available for the structures, masonry, building materials and products. I just organized it here for you. Concrete and cement, timber, because at the end of the day, these standards will guide us to conduct the test and ensure the characteristics of your material. So we're gonna have their testing procedures, terminology, and that's why we need to think about safety aspects when you are working with construction materials. And talking about safety, this is the main concern, right? Materials, construction materials, engineering materials, properties. That's why this is something that you'll be discussing here today. Some ideas about, as engineers, as construction professionals, we need to know the difference, right? This is the fundamentals. When you have selection of materials, we need to know what you want regarding physical properties, mechanical properties, chemical, electrical, magnetic properties, thermal properties, for example. And this is a very interesting diagram, if you can see here. It's normally when you have more than one property, we can think about correlations. Remember at the very beginning, I mentioned the family, materials family, metal family, ceramics, and here we can hit technical composites, hybrids, polymers. So when you need to select materials, here is an example when you have modes of elasticity against density. So depends on your project design. You need to, this is the type of diagram you need to familiarize regarding if you're looking for a lighter material but showing high young modes of elasticity, right? So this is quite difficult. Pretty much when you have here the metal families, the alloys, what we can see, higher density and higher modes of elasticity, if you think about the design. So I will not go further this. It's more to, as mentioned before, it's more to explore what type of properties we need to familiarize ourselves. And here are some examples when you have here about thermal properties. Here we can see very common. Sometimes we need to think about the thermal loads in our project, and that's why we need to understand materials, which one is the one showing high conductivity, lower conductivity. So yeah, it's important to characterize materials against thermal properties, and here chemical properties. Chemical properties, I understand, majority of times civil construction in professionals, we don't like chemistry, right? So chemical properties are critical. So we need to like it more than ever because it's about durability, deterioration, okay? So let's say here we can, even the water, we need to understand the properties of water as a material if you are producing concrete. This is my favorite. That's why I'll talk about this one. So salt water. Do you think it's a good idea? Add water, salt water in our concrete if you're gonna work with reinforced concrete? Do you think it's a good idea? Yes or no? No, definitely not. Okay. And why? This is the next question. Why? No, right, Wakamona? No, definitely not. And we have also magnetic properties, optical properties. All these characteristics are important. Corrosion, Mohammed, definitely. So now we're going to talk about physical properties, but don't be concerned about these numbers. This is about to give you some example why we need to know this, because as I mentioned, you have a new material to test. Let's say I retrieved this from the literature, very recent, 2022. So this group of researchers decided to compare different types of sand. We have natural sand, river sand, but they are considering to replace part of river sand by the other types, coral sand and sea sand. So step number one, physical properties, because we need to think about materials, concrete mix dosage, right? Concrete mix design. So these are the characteristics we need to understand water absorption, the density, if we're going to produce normal weight concrete, lightweight concrete. So physical properties just give us this type of inputs, right? Physical properties. And then from here, they can understand, then can you see coral sand presents higher water absorption? Very, very high, 4.7 if you compare with sea sand or river sand. And what's the main problem? When you work with sand, with high level of water absorption, the sand you absorb water, and then you need to adjust this at the moment that you are mixing concrete to not add more water in your concrete. So just to give you some examples why we need to familiarize with the testing, right? The other one, let's have a look at the chemical properties, right? And same here, as we discussed it before, we have all the oxide compositions here. We have Portland cement, coral sand, and sea sand. And why it is important? Because we don't want chemical reaction between Portland cement and sand. We used to say aggregates, they are inert. Inert means no chemical reaction, right? So by doing this type of analysis, uh, our colleagues, we need to work collaboratively with our colleagues, chemical engineers, and then we can come up and understand which one is most suitable for our project, if it's suitable or not. This is the point here when you are covering these chemical properties, right? So, and this also can influence the durability of your concrete later on. And now we come to one of the main concerns. Why we need to be concerned about materials, construction materials testing? Because we don't want this, right? Mechanical failure. So there are so many examples around the globe in different countries: stadium collapse, bridge collapse, oil tank fracture. So even when you have this type of failures, some of them can be predicted, right? But some not. Let's say it's a natural disaster. We can try. It is our job now, how we can design resilient structures, right? More resilient structures regarding just to cope with the natural disaster. Not easy, but the step number one when you're selecting materials, it's about mechanical properties. When you talk about failure here, straight away come to our mind mechanical properties. And this is the huge questions, right? Some of you are totally familiar with this, some maybe not. But how do materials break? It's really simple. If you apply load, the materials present enough strength, will not break. But after a certain level of load, the material will break, right? So this is the example compressive test when you have concrete, and how do materials break? When here we have, right, make compressive strength, we apply load for this one, and what we can see, the cracks are formed here, and the load increase until a certain level. So when you do this type of test, pretty much we are concerned with the material's behavior. Stress strain diagram. You are familiar with this, right? And this one is for the concrete. Let's say you apply load, you can obtain here displacement, vertical and horizontal. When you have the vertical displacement, you can calculate strain. So you apply load until a certain level, you have the linear behavior, right? And then straight away after the maximum point load here, maximum stress, you can see here the collapse. And why it is important? Because by doing this type of analysis, even with the simple compressive strength test, we can identify if our material is a ductile material or a brittle material. And other types of characteristics like fatigue, creep, we need to observe and understand how materials break. And another type of test, as Fred mentioned, is about the tensile test, right? There are some, as you can see here, there are specific samples. So it depends on the type of material. We have this specific equipment and samples that we can use. And at the end of the day, by doing the test, applying compressive load or tensile load, as you can see here, is tensile load in concrete. This is the direct test. It's very hard because from here you apply direct tensile test. Not very easy because we need these special types of this device. Yeah, when you have steel, we have the yielding point, right? For the steel, when you conduct this type of test, stress strain using steel, normally you have the linear part, the yield, and then you have the collapse. And this gives us this idea. Brittle material, straight away you have the fracture, right? You don't have time to run away. The material will collapse. And then we have moderate ductility, more or less with concrete, and very ductile, pretty much steel. So these are the information we needed to familiarize ourselves. Yeah, this is ductile. Yeah, this is the type of failure brush. And why we incorporate fibers in our materials, in our composites. Here is the example of concrete because we need this, a more ductile material. This is the main purpose when we incorporate fibers in our composites. And when we select materials, for example, in order to produce fiber reinforced concrete, we have available different types of fibers like steel, polymer, and here is the type of test that we can conduct in order to understand uh, if the efficiency of the amount, the dosage of fibers, and the type of fibers as well. Definitely, Rafi, this is our main objective when incorporate fibers. With that one, the previous one, concrete, and then can you see this very thin type of composites? This is the main point. And you can use what is available, right? Tide waste, fiber from tide waste. If depends on your country, you can use coconut fiber. From the Amazon forest, you can use jute or sisal. And its flexibility is when, in fact, when here is about the bending test, we, instead of flexibility, we can obtain flexural strength. Exactly. Thank you for popping up. Amazing. So what we have here at EIT is our remote lab. So more and more, definitely we can go to the lab and conduct this type of test if you're doing research. But at the moment that you are learning how to conduct this test, we can use the virtual labs. And that this is the one that I will be not able to do the entire demonstration today, but it's just I'm going to show you step by step how what type of information we can collect. Remember compressive strength test when you have the cylindrical sample and you apply compressive load. We can do this just to learn how to conduct the test, right? You can do this using the virtual labs. And it's quite interesting because the virtual labs, as you can, it's safe. First step, it's very safe because you cannot hurt yourself. And then you can see all the safety procedures here. You know, we need to be protected because you're gonna add your sample here in the virtual machine. And what we can do, in order to learn this virtual lab, they provide us with different concrete sorry, and by doing this, we can select if you want to compare different concrete mix. If you are interested, compressive strength, 3 days, 6 or 20 days. So here you can see, depends on as we are talking about concrete, we can plot the strength development gain over time. We know our main reference when you are working with concrete, it's about the 28 days because you have the hydration process of cement particles. So, but we have compressive strength over an age, right? So this is the type of test we can conduct in a virtual way using at EIT using our remote labs. We can do, Edmund, we can do 14 days as well. But these are in order for you to train, just a question of training and familiarize with the procedure. For example, here you can see we have the samples, the concrete samples, depends on your country. You can use cubic samples or cylinders, but virtually you can just grab the sample, put into the machine and apply loads. And at the end, we can observe the load here and you can take notes. So this one definitely is targeting learning, how to use this, and then about analysis, right? Because let's say for this example, I just got the mixture one, and I just selected 28 days, right? But I can do the other days, 3 days and 7 days for this one. And now we have the cubic sample, and then we can calculate. For the 3 samples, we can calculate the strength, right? And yeah, so this is the type of activity we can conduct in order to offer some practical and hands-on activities to our students. And we can, as I mentioned before, have 6 mixtures. We can play with these mixtures in a safe way. And yeah, this is one of the points, just to show you how we can improve, how you can train and practice before go to physical lab and do your job. And yeah, we talked about the properties, and we're gonna be finishing soon. It's about deterioration. We need to understand the chemical properties, right? Mechanical properties now we are clear. We have compressive, tensile, flexural, and now we need to understand materials degradation, right? We have, when we study durability and materials testing, we need to understand progressive degradation, gradation caused by shocks, and progressive shock plus basic deterioration. So this is a very interesting area, because when we never know, you have opportunity to work as a forensic engineer. Something is not going well, or some part of your structure collapsed. We need to understand, to figure out what happened, right? That's why here is more to give an idea about planning and conducting in situ inspection. You have 3 main stages: visual inspection, hands-on, and testing. It's all about testing. Materials is about testing. And when you talk about testing, we have these 2 main alternatives. Destructive, as you could see, unless we are doing virtually in our virtual lab, we can destruct and reuse, but in real life it's like this, right? Destructive, we cannot reuse our sample. The sample is destroyed. And the other one is the non-destructive, right? Are you familiar with non-destructive tests? Have you heard about an example like this one, the ultrasonic pulse velocity, Smith hammer, rebound hammer? So yeah, that's great. So this is, as you can imagine, very, very useful. And then you can apply this type of test timber, so you can have understanding about what's going on with the timber species. Yeah, rebound hammer, Edmund. And here is an example of this type of test that could be used in timber. Another point here, ultrasonic pulse velocity. Here is an example when we worked with carbon nanotubes, and then we'd like to understand the modes of elasticity of carbon nanotubes. And even in the lab, we can use the ultrasonic pulse velocity. And the other one, resonance frequency. So these are the alternatives we have in order to get better idea about materials characteristics, and we don't need to destroy the sample. And when you do this type of test, normally this is more to compare. We have the pros and cons. According to the standards, we can evaluate. Normally, nowadays, there's more a combination when you combine more than one type of ultrasonic test and plus Smith hammer. So because, Smith hammer is about what's going on at the surface of concrete, like hardness test. That's great, Sammy. I really like this one. I worked a lot during my thesis. And this one is a pop-up quiz for you. Just let me know, what is the pH of hardened concrete, in order to ensure that your steel bars are protected. Can you recall this? This is more to memorize, right? The pH of concrete. And then we can move on. A bit more. 7, what do you think? A new, yes, Edmund, thank you so much. I will pop up in the chat box for you, right? It's about, approximately, okay? So these are the corrosion is quite important. And then we can have some, these I don't go into the details of this, but to illustrate that we have a variety of tests that we can conduct in order to have a better evaluation regarding corrosion when you are working with steel. pretty much reinforced concrete or pre-stressed concrete. And yeah, the other part here, it's about other types of tests that we can conduct because cracking, it's another headache. If you agree with me, electrical resistivity test, it's in situ test, is this one regarding the possibility to detect the moisture of your concrete. We can also be linked with the presence of water. So this is also to understand if you have cracks, the corrosion, you progress in a fast pace, right? That's why resistivity gives us an idea about corrosion rate. So again, it's just to illustrate. And if you, depends on the opportunities you'll be working, like this guy here, in order to inspect and monitor a breach. So we have, this is another area, right? Monitoring that you can explore, but the fundamentals to move on and in order to be expert in this area is to start with the fundamentals of construction materials, right? I'm just sharing here. So some benefits just to keep the structure monitor to avoid any problems about degradation, you can keep an eye on, you can have sensors nowadays, you can get information about displacement, all this in order to ensure the safety of your structure. So here there are some strategies, type of parameters that you may need, that you have it this in your, later on you can keep these slides with you. This is part of one of our units, master course. And here is more to illustrate, right? What type of new technologies we have around this topic here, structural health monitoring. You have drones, you have digital cameras, smartphones, integration of these technologies in order to ensure that the monitoring is done properly. And the other part, this is how you give you some time. It's just to double check. It's a quiz. Let's say here you have construction materials trends 1, 2, and 3. Just sustainability and eco-friendly materials, advanced composite materials, smart and intelligent materials. So self-healing concrete, let's cross-check. Which one is about self-healing concrete? 1, 2, or 3? Yes, 3. That's great. One may. Oh, good. Thank you all. And here is about recycle, the second one. So this one, self-healing concrete, let's add number 3. And what about recycled, renewable materials, low carbon footprints? Yeah, this one. 1 or 2? What do you think? Thank you, Damien. Thank you. Yes, here we have 1. And just to give architects some possibility to innovate and create design unique. Yeah, this is definitely number 2. So it's good to know that you all are awake and keep an eye on the slides. And we have more now regarding testing. So there is another one that I want to. About mechanical properties, let's start with this one. About mechanical properties. What do you think? We're gonna talk. We talked about mechanical properties. We talked about durability, non-destructive tests, environmental impact assets. I'll give you some time just to put the order here. The first one, evaluation without causing damage, right? Definitely talked about this. We don't need to destroy our samples. And about freezing toil resistance, corrosion resistance, and weathering. It's about, what do you think? Number 2, number 1, number 2, right? Thank you. And materials properties through their life cycle, like energy consumption, recyclability, carbon emission, environmental impact asset. Examples. Yeah, this is the last one, right? Number one. Yeah, you nailed this. Thank you very, very much for your attention. And here you have some very good reference that you can later on explore a bit more. I try to summarize as much as I could to share with all of you today. That's great, isn't it? So, Lisa, that's all from my side. I I really thank you all for your participation. Very interactive session. You're gonna receive this, right, Elisa? Lisa, I hand over to you. If you have other, this part, I think is about the coming course, right? And Lisa, maybe you just provide then my email into the chat box, or you can just search at the EIT website. And if you want to discuss further, I'm more than happy to get in contact with you. I think today is a very short period of time. Thank you, Lisa.
Okay. Thank you so much for that very informative session, Dr. Anna. I'm sure that our attendees here have learned a lot. And for those who are asking for the certificate, don't worry, we will be posting that in here. So just for these upcoming courses, again, just go to the website. Hold on. Let me share the slide again because the QR code is there. Please bear with me, guys.
Okay, thank you all. Really appreciate it. Thank you, Raj.
All right. Okay, so aside from the upcoming courses that we also have upcoming events. Are you seeing the slide right now?
Yes, yes, Elisa is clear.
Okay. Okay. So we also have upcoming webinars here. So just go to our webinars page. You have the link in there for you to be able to join the upcoming webinars. And we also have our certificate of attendance that we can request from here. You can use the QR code. You can also use the link that is in there. I am now pasting the link on our chat box. So you can scan the QR code. Make sure you fill out the short form in there because if we don't, then we won't be able to receive the certificate if we don't request for it. Okay, I have posted the certificate link in the chat. So you can go ahead and copy that, and you're welcome. Okay, just copy that and answer the short form and you'll be good to go with the certificate. Okay, all right. And do you still have other questions that you'd like to ask me or Dr. Anna? This is now your chance. And these are also our contact information. You can see there our website, our physical address. We also have our phone numbers. If you'd like to speak to me or to Dr. Anna, I can answer your course inquiry questions. And for technical questions regarding this topic, it will be for Dr. Anna. And we also have an email address here for your webinar concerns, and that's going to be webinars at eit.edu.au. All right. And other contact information. There's also a link there for our um, course schedule page. So if you go there, you can see all the upcoming intakes that we have for all of our available courses. So does anybody have a question? Yes, you can get a slide of the presentation. We will be sending that through a PDF, and that will be in 2 days' time from now. Okay, you'll be receiving that, as well as the recording. For questions about the materials, you'll be sending a copy of the slides as well as the recording of this webinar in 2 days to your email. And make sure that you answer the form, the short form, so that you will be able to receive the certificate. So I am sending again the certificate link so that you don't really have to read back. For participation in this one. We also thank Dr. Anna Evangelista for that wonderful presentation. Very informative, and we learned a lot. And we hope to see you in our next webinars. Thank you so much, everyone, and I hope that you enjoy your day.
Thank you, Lisa. And I think only one student asked about self-healing concrete. It's more about durability, right? The main idea to incorporate some bacteria in the concrete is they discovered that it's possible to mitigate cracks propagation. So we're gonna help with the durability of concrete. And you
Okay.
have any other questions, please feel free to email me. Thank you, Lisa, for your time. Thank you very much.
Okay. Thank you so much, too.